Hey Pre-Cal, I have your notes pulled up for 3-1 and 3-2, day 2. So what we've done basically is kind of giving you a taste of exponents and then a taste of logarithms. And now that you've practiced a little bit with both, let's move on and look at what their graphs look like. Let's look a little further into their graphs. So on these notes, you're supposed to have this graph memorized. I've already told you that. I'm not telling you something else to memorize. I told you a couple days ago to have your basic exponent graph memorized, what the equation looks like, and what the important point is on it. Looking at this graph, you should be able to answer all of these questions over there about an exponential function. So you might want to take a minute, pause the video, and maybe just try to answer them on your own if you can. Now, I would like us to actually graph an exponential function using actual points, not just a rough sketch like that one up there would be. Let's use actual points. So what I did is I set up an XY table just like you would have. I chose a few fairly nice X values. I chose -1 and 0, 1, 2, 3. Plug them in. 2 to the -1 power is a half. 2 to the 0 is 1, and so on. And then I plotted them. Zoom in here a little bit. But I made points for all of the ordered pairs that I created and then drew the curve through them. Once I got the picture of the curve, then figuring out what my domain is easy. Figuring out what my range is easy. And identifying that there's an asymptote at y equals 0 is easy. So in my opinion, doing domain, range, all that stuff is easier if we have a picture. So I went ahead and got the picture before I answered those questions. Here are just some calculator tips down here on if you're graphing exponents in your calculator. Make sure you use parentheses when necessary. All right, moving on. Logarithms. Again, I have the basic logarithmic graph here for you. The basic shape. It never touches the y-axis. Important point. You need to memorize that. It's not something in addition. It's what I told you yesterday in section 3-2. You've got to memorize that. If you have that picture, I think all of you can go through and answer these questions about a logarithmic function. So you might want to take a minute, pause the video, see if you can answer those questions on your own. Now, what I'd like us to do is actually graph a logarithm, not just a rough sketch, not just, here's kind of what it looks like. Give me actual points on a logarithm function. Well, here's the problem with that. We're not good at logarithms. We're not good at making up points that work in a logarithm. But I want you to do it anyway. So what do you need to do in your brain in order to work with this logarithm? You need to switch modes. You need to switch to exponential mode in your brain. So here's what I did. First thing is reverse the equation. So write it the way that I told you. Put your log over here and put it equals y. That way you can grab the exponent and swirl around. And so I would rewrite this as 2 to the y power equals x. A little bit weird, a little bit not what you're used to, but way better than trying to plug numbers in here, right? So 2 to the y equals x. This time the y's are the numbers we want to plug in, and the x's are going to be the answers that we get out of it. So I went ahead and set up a few y values to plug in. So I've got 2 to the -1, 2 to the 0, 2 to the first, 2 to the second, 2 to the third. I take those combinations, 1/2 comma -1, 1 comma 0, and so on, and plot the ordered pairs on the graph. That's what it looks like. Once I get the graph, then answering domain, range, and asymptote questions is easy. Now, let me talk to you a little bit about some transformations on graphs, whether they're exponential functions or logarithmic functions. So I think the basic thing that I need to go over with you is, like, you know horizontal comes first. You know you're doing a horizontal transformation. Things in the equation are backwards from what they appear to be. But there's one thing that's super, super important with an exponential function and dealing with what's horizontal, what's vertical, like what's inside, what's outside. When you are looking for horizontal transformations in an exponential function, what's in your exponent is always the horizontal stuff. Anything up here with the x, horizontal. I would highlight it pink based on the colors that I chose like weeks ago. Anything hanging off at the end, vertical. You knew that. Here's where people get confused. Your base is not a transformation. The number in front of the base is a vertical transformation. Okay? Your base can be anything. Your base can be 2, 4, 6, 10, 7, 11, whatever. That doesn't really change the graph much. Anything in front of your base is what's going to do your major vertical stretching or compressing in your graph. Okay? So I've shown you where those are. And in a logarithm, anything hanging off at the end is a vertical transformation. You knew that. Anything in front of the word log is a vertical transformation. So anything up front or in the back, I would color blue. And then within your logarithm, now I'm not including the base, okay? Ignore the base. Just like, see, the base never gets colored a pink. It never gets colored blue. It just stays what it is. So don't look at this. Only look at what you're taking the log of, right? Because if you would read this, you would say log base b of x. Whatever we're taking the log of, that is all considered where horizontal transformations go. So here is, let's see. Here's a function. It's an exponential function. I've got 4 times 6 to the negative 0.2x power plus 1. Obviously, vertical transformation. See, this is the base. I didn't color it. It's the number in front of the base that gets colored. That's part of a vertical stretch. And then everything up here within the exponent, that's all horizontal. And 0.2 is the same as 1/5, so keep that in mind. Ready? I'm going to list them. I went horizontal first, and I even color-coded them pink. So the first thing that's going to happen is I'm going to read this from left to right. There is a flip. There is a horizontal flip. Let's see, horizontal goes this way. There's a horizontal flip over the y-axis. And if this is 1/5, does that mean that there's a horizontal stretch by 1/5? Oh, good heavens, no. Remember, it's backwards. So it's actually a stretch of 5. Horizontal stretch of 5, not 1/5, 5. It's backwards from what you would think. Use the reciprocal. And then for the last 2, remember, left to right, so I'm going to start in the front. The 4 is a vertical stretch, and the plus 1 at the end tells us to move up 1. Next one. Before going any further, well, first of all, I highlighted everything. So this is all exponent, so this is pink. This is the base. Don't touch it. Don't color it. This is the stuff in front of the base, so it all got color-coded blue. And this is hanging off at the end, so it got color-coded blue. Now, the only thing I did before I got started is what many of you will forget to do, and that is pull out the 3 off of the x on your horizontal transformation. So I pulled the 3 out of both terms. Pulled the 3 off the x, and here's what I got. Divided out the 3 from the 4, and here's what I got. Recolored everything. Now I'm ready to list my transformations. We're going to start with pink. So we're going to go, is it 3? No, it's horizontal. It's backwards from what you would think. So a compression by 1/3. And then, oh, that's a negative. Does that mean it goes left? No, it's horizontal. It's backwards from what you would think. So it moves right 4/3. And then for the blue, there are 3 things. I see a negative, I see a fraction, and I see the -3. So 3 vertical transformations. The negative does this, the 1/2 does this, and the 3 does this. Now, there were some complicated transformations going on in those 2 problems. So we're going to skip identifying domain, we're going to skip graphing it, we're not going to do anything like that. All I wanted you to do was be able to identify inside, outside, and list them. Okay? Now, let me give you a simpler one. And I want you to state the domain and the range and all that stuff. So, it says, transfer a normal logarithm with base 4 to this one. Transfer a normal logarithm with base 4 to another logarithm, same base. So I colored the horizontal transformation. This is what we're taking, the log of. This is horizontal. And then the +2 is hanging off at the end. That's vertical. Now, keep in mind, remember I want you to memorize this. A normal log graph, know the shape, know the important point, and know the asymptote. It never crosses the y-axis, okay? So I've drawn an asymptote kind of in orange, asymptote at x = 0. The important point is 1, 0, and I've drawn the shape of the graph. That's for a normal logarithm. Now, let's look at this one that's been transformed. So our new logarithm has now been shifted left 5 and up 2. So what I need you to do is I need you to take that normal graph, shift it left 5 and up 2. So, 2 things. 2 things I want you to move before drawing your graph. First of all, move your important point. So, my important point was at 1, 0. I want you to move the important point left 5, 1, 2, 3, 4, 5, and up 2, 1, 2. Put it out there. That's our new important point. Now, the next thing I want you to move is your asymptote. Our asymptote used to be here. All right? Take that asymptote. Move it left 5. 1, 2, 3, 4, 5. And move it up 2. Well, that's silly. It's a vertical line. There's our new asymptote. So what I need you to do is I need you to draw your logarithm graph, get it really close to your asymptote, come up, come up, come up, come up, pass through that point, and then keep on going. Follow your asymptote, don't touch it, go through that point, and then keep on going. That's what it should look like. Now, once you have the picture, I think domain and range should be easy. Old domain, we'll go back on your old graph. What x's were there? Well, x had to be greater than 0 on the old graph. What about on the new graph? Does it cover all the x's? No. It's never going to touch -5. So x is going to be bigger then negative 5. Old range, how high and low did it go? Well, it covered all real numbers. New range, new graph, how high and low does it go? It's still going to cover all real numbers. This one's supposed to say, where was your old vertical asymptote? Well, it was at x equals 0. That's the one it wasn't going to touch over there in that picture. Where's your new vertical asymptote? It's at x equals negative 5. There you go. Transformations, I highly suggest a pink and a blue highlighter. Do not highlight your base. Not in an exponent and not in a logarithm. Don't highlight your base.